So you guys have a test on Wednesday that is on Delta Math. There is a review that is out on Delta Math that is due, I think Wednesday morning. I gotta check. Well, so that Friday was kind of a half, not super instructional day. And related rates are long, complicated problems now. These are, that I just gave you, they're out of the textbook. We're not gonna do all of them because they do take a long time. Yeah.
Are we gonna, when we do the test Wednesday on Delta Math, are we gonna get points taken off, or is the work collected
If you
just to get
get
points
it
back?
wrong, yeah, you're gonna get points off if you get it wrong.
No, but
But yes, the Delta Math doesn't, there's like no partial credit. So I would like I said, I'm gonna collect work for the test on Wednesday. So keep your thoughts organized. Challenge for the bulk of the class. Number one, write your work out.
Are you gonna get partial credit?
Potentially, if I have to take too much time to figure out what your question is and what you're answering and what your logic flow is, I'm thinking no. But if it's obvious that you just like, oh, I multiplied by the power, lowered the power, and then drop the negative sign. Okay, understandable. Yes, Tessie.
Are we gonna get a calculator for the thing? Because it wanted the weekend one wanted like 3 decimals.
Right. So there are things that need a calculator, and there is a calculator within Delta Math. It's more of a pain to use, but there is one on there. Yep, indeed.
So we can't have our calculator during the test.
I need to talk to Ms. Bowman to see what we're gonna do. There will be access to a calculator, but it might not be as convenient as the one that you have. Yeah.
Really, one decimal off.
Delta Math will ding you, and I can see your submission. I can see what the actual answer is, and again, I'm collecting work.
So is there like a margin of error that we can be in between, or do we have
Okay.
to have like?
For the AP exam, and this is why there is a review on Delta Math, for you guys to be familiar with the interface, and for you to understand that it gets a little testy when you add extra parentheses. And those are not wrong, but it used to, 2 years ago, when we were over COVID, if you said parentheses, squared, it said no. They fixed that, but, so I can see what you've done, but you need to show me spelled out work so that I can go through and look to see, was it just a simple mistake? Or do you not know what the hell you're doing? Okay, so the things on the check, yes, Brooke.
But on the Delta Math, they're gonna give us like those equations, right? For like the volume of the air.
If you need volume equations, they will give you volume equations. They do not give you any area formulas. So you need to know area of a formula, or area of a circle, or a triangle, or a rectangle, stuff like that. So the kinds of things, Mael, did you not get one? Keith, did you get one of these? You came in late? No? Anybody else missing one? Isaiah, do you have one or no? Here you go. Disperse.
I have a question. So if you have,
Okay, hold on, before we get to these specific questions. Chapter 4 is 4.1 to 4.3, which is what the quiz was on, and then the subsequent retake. Doing the first derivative, what does that tell you about the function? If the first derivative is positive, that means the slope of the function was positive, so it's going up. If you can do the derivative, it means it's a smooth wiggle. If the second derivative of that thing was negative, you know it's some kind of frowny face with no other wiggles to it until you hit the next critical point. So you need to know things like how to find the first and second derivative, how to find their zeros and where they are undefined. What is a critical point? What is an inflection point? What do those things mean? What does it mean for the first derivative to be positive? What does it mean for the second derivative to be positive? What does it look like? How do you find the absolute maxes and mins? That's all 4.1 to 4.3. 4.4 and 4.5, or 4.6, which is this, those are the dreaded things of optimization. What's the best shape of fence or perimeter around a rectangle where you can get your little puppy, the most space? A circle. And actually putting a circle in fencing sucks. You wouldn't do that. That would really, yeah. You ever dug holes for a post before? Not a party. And for a rectangle, 1 post, 2 posts. Fido's gonna run in a rectangle, okay? All right, and then linearization is 4.5. Hopefully that one's easy. Carson, what was linearization? What does linear mean?
Means a line.
So what do you think linearization means?
Has to do with some lines.
Thanks, yes,
Nailed
Has
it.
to do with lines.
nailed it.
Attaboy.
So linearization is if you have this curve and you want to know what's going on right at this spot, linearization is make the curve become a line. So find the tangent. So that was part of it was on the dots math yesterday.
So you're finding the slope of the tangent.
So you would find the coordinate on the red coordinate. You would find the derivative of the red line and the slope of the red line.
It's
And you would create this, you would do the derivative, find the slope. And then if you were close enough around that point of tangency, using the blue line to find the value is easier than using the red line. That's what linearization is. All right. I want to try this problem first, and then we'll go crazy and we'll let Isaiah pick one of the other 5. Okay. Okay. Let's read the problem. That is always step 1. Here we have a 13-foot ladder leaning against the house. They gave us a picture. The base starts to slide away. This is my fear anytime I get on a ladder, is that the bottom is going to get yanked out. It's starting to slide away, and it is sliding away at 5 feet per second, and we want to know how fast this is falling. So what are all the things that I know? Nick, what's one thing that I can pull out of this that I know?
The base is moving at 5 feet per second.
So how am I going to name that?
B dB over dt.
Okay, I'm going to call it x because in the picture they gave me x. dx dt is 5. Is it positive 5 or negative 5?
5 positive.
Positive because it's x is getting longer, right? The ladder was here and then it got pulled out, so the x length is getting bigger. Will, what is another piece of information that I know?
On the actual image, the base is 12.
On the actual image, the base is 12 because they told me. Liv, do you see something else?
Oh, it's a 13-foot ladder.
It's a 13-foot ladder. Okay. I don't know what we want to call this. H for hypotenuse. Isaiah, how is the hypotenuse, the ladder, changing? How is the length of the ladder changing? Well,
It's not changing.
it's not changing. It's a 13-foot ladder. Just is. So what does that make the change in that?
Makes the change the angle.
Um,
Oh, you're saying what I was. I got it.
So that it's a constant. It's not changing. It's 13 feet, 13 feet, 13 feet. Whatever it is, it's sliding down the wall at 13 feet. So that looks like all the givens. David, is there something else I can pull out of this?
Well, the y value at that time is 5 feet.
How do you know that?
Well, I just remember that 13, 12, 5.
Y squared plus x squared equals hypotenuse squared. So I agree. Y equals 5. Do I know dy dt? How y is changing over time?
That's what you're trying to
That's what I'm looking for. Is it going to be 0?
No.
No, like the ladder is sliding down the wall, so it's not going to be 0. But that is the thing I'm looking for.
I don't know.
Yeah.
So like as it's moving, right, dy dt would be negative. Right.
Okay, dy dt better come out to be negative, and if I get it,
That's what it should
you're
be,
right.
Okay.
And if
just
I get an
wanted
answer that says 70,
to-
we should know that's
Okay.
okay. So these are related rates. I need to tie these 3 things together, right? What is an equation that can tie all of these lengths together?
dt, dx, dt, x, and h.
Okay, I need an equation not derivatized yet. I didn't do the derivative yet. I need something to tie them together. Natalie, what were you going to suggest? Pythagorean theorem. X squared plus y squared equals hypotenuse squared. Okay, Simon, I need to do the derivative of all of these things with respect to time. Not x, not y, not h, but time. So what do I get?
2x dx dt plus 2y dy dt equals 2h
Okay, Mayel, do you see one thing that I can, there's 2 things that are kind of nice that I can clean up, but what's one thing I can do?
To
Reducing everybody by 2, okay? Do I know x? It was told to me in the problem, that's 12. Do I know dx dt? 5? Well, what were you gonna say?
I was just gonna say it would equal 0, right?
Okay, and do I know the y value? Yes, David found that for us, it's 5. dy dt is the thing I want to know. And Walt said, isn't that going to equal 0? Because h is 13, but the change in the length of the ladder, the change in h is 0. Huh. I see the answer right now. Francis, what do I do from here?
16.
So 12 times 5 is 60, and she subtracted it to the other side. dy dt is negative 12. Mikhail, what's the units? Feet per second.
Wait,
Okay.
why was dht 0?
We have a ladder, static wooden ladder.
Yeah.
That doesn't do the slidey thing. It's not
Okay,
like rubber Armstrong ladder that stretches or anything.
So there's
No changing in the length of the ladder. Yes.
What if you don't cancel out the 2's? Then you get negative 120.
Divided by
-10.
negative 10. Like
Oh,
Mael said we can reduce a 2 from everybody. If you don't reduce a 2 from everybody, then you would get that 120, but divided by a 10 instead of dividing by a 5. Well,
So this all makes sense, like how to find and everything, but what are there a certain amount of I don't know how to ask, you know how there's equations that you're gonna know, so like Pythagorean theorem, where law of
okay,
both sides are law of sides.
there's 2 other pieces to this that are going to make it harder.
Okay, so I guess are there multiple, what are our
Okay,
options here,
the point of these couple questions is I'm going to try to get through as many of the, well, how are you going to make this related rates thing go? And a lot of them are triangles. Not all of them, but a lot of them.
Pythagorean theorem seems relatively easy, but when it comes to law of both
All right,
sides-
we'll make it harder.
No, don't make it.
chill out.
Just let you know, part 3 of this, we'll make it harder. Yeah.
When it says on the Delta Math test, or on any test, I guess, if we say if we don't say negative 12 feet per second, we're just saying it's falling down at 12 feet per second.
Okay, they want a number, so you're not gonna be able to type in the words falling down at 12. They want it negative 12.
Okay.
There was another,
I mean, I kind of understand, but how did you get a dx over dt from by the time the base is 12 feet from the house, the base is moving at the rate of 5 feet per second? Because
so the little red arrow in the picture, it says the base is moving away from the wall at 5 feet per second. that means dx dt is getting longer. It's like running away that way. Yeah?
Yeah.
Josh, what does part B of the question say?
To find BADT, the area as the ground changes.
Okay, so, well, here's the question you were asking about, and I don't think it's a nightmare.
Yeah.
At what rate is the area changing? So what do I need an equation for? Area of the triangle. So what is area of the triangle?
1/2 base times height.
Okay, and in terms of the letters that I have, what is 1/2 base times height?
A equals 1/2. I guess your base would be 12.
Okay, hang on. I can't. Is the base moving? Is the base length changing?
Yeah.
So I can't
Oh,
plug in a number. I
So
need
X.
x. And the height,
Well, height
is that changing or
is
can?
also going down, so Y.
Okay. All right. So they are both varying. So they are both variables. I can't plug a number in. Nico, the change in area over time. What is the derivative of this product?
It's y 1/2 dx dt plus 1/2 x dy dt.
Okay, so he said he did the whole thing right. I wrote it differently. I have the 1/2 factored out. Is that okay? Yeah. So you sorry?
Yes.
Okay. We can do either way. Do I know the y value, Iris? In the problem, what is the y value?
At the moment, it's
At this snapshot in time? 5. Okay. So the change in area is 1/2 of 5 times, do I know dx now? We just calculated it. Asher, what was it?
It's 5.
Dx. I erased it. Dx dt. Oh, dx dt. Plus x, which was in the problem 12. Dy dt is the thing we just calculated. Amalia, what was dx dt, or sorry, dy dt that we just calculated? Negative 12. So the change in the area, 25 minus 144.
25 minus 144.
Uh-huh.
29, negative 129.
And then over 2.
1 negative 119.
Negative 59.5.
What?
Oh,
divided by 2.
is it not times 1/2?
It's divided by 2, yeah. You're right.
What?
So does it make sense that I got a negative number for the area? Does it look like the area is getting smaller? Yes,
Yep.
because when the ladders flatten the ground, I'm going to have 0 area left. Mael, yes, no, or can you just not see?
Well, all of that, but the derivative of the area, can you read that formula?
Okay. So the derivative of the area, derivative of the area, Nico, exactly the way Nico said it was, area is 1/2 x times y. He said dA dt is the first times the derivative of the second plus the second times the derivative of the first. And then we plugged all those numbers in. And because we solved part A, we had all the numbers that we needed to plug in over here to find our change in area. So, well, this was a different one than Pythagorean theorem.
Yeah.
But, like, area of what? It was a triangle shape. Scary or?
No, I guess like what I was
Is that
trying
right
to
with
ask
119?
was if it wouldn't be a triangle, like
Sorry?
I guess I'm trying to ask like if it wasn't a triangle, like if we weren't trying to if it's always a triangle, we always use using Pythagorean theorem to find out like dy dt.
Right here we did part B, which was not Pythagorean theorem.
I get that. I'm just saying if it's asking for like
Okay, part C. Let's look at part C.
alright.
It's still a triangle, and no, it's not Pythagorean theorem. Lanham, this is
Yeah.
asking. Oh goodness, we're not doing log cosine for this.
Okay, that's what I was asking basically. Is it gonna get that bad?
Okay, these can be wicked. Trust me, they're six.
No, I believe you. I just, first, I got that.
We believe that you know how to make math uncomfortable.
Okay, good talk. But Lana, right here, it's asking, how is this angle changing as the ladder is going? So I need an equation to connect that angle and something.
Yeah, I would use sine.
Sine, okay?
Use gravity.
Sine of theta equals what?
It's y over the hypotenuse.
Y over the hypotenuse. All right.
What?
Do I have to use the letter H for hypotenuse, or can I plug the number in?
You can look at
Why can I plug the number in?
the
Because it's not changing. It's a constant. Okay. How are your trig derivatives, people? What's the derivative?
cosine.
Okay. Okay. Derivative of sine is cosine. Yeah. All right. And
Wait, what
you.
was the one then where it was just disgusting, ugly, like negative one over, like.
Secant sucks. Secant inverse. We'll do that one later.
I don't want to
Okay,
remember.
wait. So this, I'm not done. Derivative of sine is cosine, and then the derivative of the thing inside with respect to time. Mael, do you know what I'm missing?
Why sine?
Oh, okay, let me finish one phrase though. D theta dt. If you don't put that in there, you have just lost the thing we're looking for. And then this, 1 over 13, and the derivative of y with respect to time is dy dt. Okay, Mael, y sine. This I knew was 5 because it was given. This I knew was 12 because it was given.
Because derivative y is
I could choose sine. I could have chosen cosine. I highly recommend you use something that uses that static, not changing hypotenuse. And sine, we just learned sine first when we're comfortable with it.
But we don't have theta over.
Okay. The theta dt equals 1 over 13. What was dy dt that we calculated already? Negative 12. Okay. And then times 1 over cosine theta. Walter says, we don't know the angle, and I'm not letting you use a calculator on this. Looking at this triangle, Eric, do I know what cosine of theta equals?
Give me a sec. Yeah, I'm sure we do.
Look at the numbers on the sides. Cosine out of the SOHCAHTOA. How do we spell SOHCAHTOA?
So, then over.
Cosine is adjacent over hypotenuse. So what is the adjacent to theta? Carson says 12. Adjacent means next to. There's two sides that are next to that theta. Why is it not 13? Because 13 already has the name of hypotenuse. So the other dude is 12, is the adjacent. So negative 12 thirteenths divided by 12 thirteenths. Dividing by that is multiplying by the reciprocal. So this is negative 1, and the units of measure is radians per second. Sorry, Brooke, what was your question?
My other wondered, how do you get from y over 13 to why do you just change the y for 1? And also, if you really know the value of y, why don't you?
Okay, because y is changing. The ladder is sliding down. It is moving down. It's not 5 all the time. At the time we took the picture, here's poor Mael up here, and he's like, oh no, but he's still moving. As for this thing, are these the same? And is this the same? Like all of the, like the numbers on the bottom are dividing the stuff that's multiplied on the top. This was a 1y divided by 13. I just pulled it apart like that. so that I could say 1/13, then how is y changing over time? Good?
So, but you're finding the derivative of all of that, right? Like 1/13 times y.
Yeah. Like, in this equation, I have the angle is changing and y is changing. The 13, the ladder with static length, not changing, so I plugged in the number. So derivative of this with respect to time gave me this d theta dt.
This is -1 per second.
-1 radians per second. Yeah.
At sine of theta equals y/13, is it possible to do like arc sine and then do derivative of that? Or do you not?
That I don't let you use a calculator.
Yeah.
What is arc sine of whatever it came out to be, -12 or 13 or whatever?
Like,
You wouldn't know.
Yeah.
You wouldn't know. And I can do all this without a calculator, and I got the answer of -1. I mean, don't use a calculator. Yeah.
Find out the derivative. Did you use power law?
This derivative here,
No, the derivative. Yeah, the derivative of that.
the derivative of this, derivative of sine,
Well, yeah. I know that's-
and this one, I guess it's power rule. Multiply by the power, which was 1, lower the power, and it became y to the 0. And then I needed to do the derivative of y with respect to time. How is y changing over time? We have a name for that variable. It's dy dt. What?
What 13?
The 13 is just there. Oh, okay. I'll hang on. Can I erase all the mess? You sure? Okay, we're gonna erase all the mess. Spinning wheel of death. Maya, what's the derivative of this?
Is that a 3 or 5?
That's a 5, sorry.
And x to the 4.
So you had no issue with the 2 being there and you just multiplied it.
Right.
What is the derivative of 1/2 x to the 5th?
5/2 x to the 4th.
Whoops. So the 2, you were okay that it was there and we just multiplied by the derivative. We did that with that 1/13. Why? The 13 was just in the bottom, just like this 2 was just in the bottom. My out was 1/13y, multiplied by the power which was 1, lower the power which was 0, and then the derivative of y with respect to time.
I get it. Thank you.
Okay. All right. Looking at some of the other problems on here. Our conical reservoir again, water falling. We have a cone. We could do another triangle, and a cone and a cylinder. Yeah, there it is. Okay, this is why this is on the sheet in front of you.
Yikes.
It's all just because I love you. Okay. Pull out all the information you know. Try to write these things out organized. And I promised I would give you guys volume formulas when you needed them. Volume of a cone is 1/3 pi r squared h. Volume of a cylinder is 1/3 pi, Whew. If you need them. Keith, any idea how to start any of this?
Is it not all 10 inches cubed?
Wait.
Yeah, okay. What do we label the 10 inches cubed per minute? Is that height? Is that radius? Is that volume? Is that volume increasing, decreasing? Is it in the cone? Is it in the cylinder? Like, what's going on?
Decrease volume.
It's decreasing. What's the name of the variable? dV/dt. How can you tell it's volume?
Inches cubed.
Inches cubed is really the biggest thing. So the amount of coffee, and it depends if we're going in the cylinder or out of the cone, whether it's positive or negative. Brooke?
When you take the derivative of the formula for the volume of the cone, can you go through that slowly?
Okay, we will try. But these guys up front are saying we're dealing with the cone right now, and the coffee is leaving the cone, so the volume's getting smaller. So that's in the cone, but if we're talking about the cylinder, it's positive. So
Is
if
that
I
how you would want us to just draw the little shape?
you can,
Or could we write like code on this?
whatever you want.
We do the same thing for
Okay, the sheet's in front of you.
Isn't, because will the proportions always stay the same as the cone? Because really the cone's, it's never 6 inches, 6 inches. So is it really just the dimension cubed?
Okay, this is a big, really key question. Brian, what do you think? He said, do the proportions always stay the same? Is this blue
Yes.
radius to height the same radius to height as the red one?
Yeah, yes.
Yes.
Okay.
Oh, wait. No, it's gonna go down, right?
Okay, okay.
It's similar, right?
Or the radius
Oh, the
is
radius
doesn't
but
change.
This diameter is 6, so the radius here is 3, and
It'll
the
always
height
be 3. Yeah.
is 6. Like when it's totally at its maximum.
Yeah.
Radius is 3, height is 6. What if the radius is 2? Do I know the height has to be? Okay, well let's see.
Does it not have
3 to 6 is radius to height.
Yeah.
Oh, I guess it's different.
So whatever the radius is, the height will be doubled. Does that ratio have to be true all the way throughout?
Yes. Yeah.
Yes, because the most hated thing from geometry, these are similar triangles. I have this angle is the same in both triangles by reflexive because it's the same damn angle, and they both have a 90 degree. So by angle, they're similar triangles, which in math means the ratios of these things are the same. Sorry, that was long-winded, but there's your proof.
That's true on like all codes.
Yeah, and now that I say that, so Lanham, I like do these into the ground because they come up.
Yeah.
And of course, they gave them a stinking funnel, which looks like a cone, and that doesn't hold the same radius. I don't think they'll do that to you. Sounds good. But I have no guarantees. But I was like, yeah, it's always gonna be the same. And the kids are like, it was a funnel, Miss Pascal.
Why don't you just write the AP test?
Because I have better things to do.
That's like how you have before.
Like smoke one in their house, keep warm.
Burns. Anyway,
BC one or the AP test?
BC.
Okay, yeah,
However-
maybe no
You get
funnels.
that
I think
right.
that's just guaranteed.
They had to.
No
Anyway.
funnels, there's no funnels.
Okay. So I think we should answer this question first because that's where we're headed. How fast is the level in the cone falling at this moment when the height of the coffee is 5 inches deep?
Wait, if you
So Brooke, here we go. Whoop. Alright. Are we okay with me using the stuff in here? Mael, you're good with where this came from? Okay. So whatever the height is, the radius is 2 of them. So Brooke, I'm gonna say the volume of my cone is 1/3 pi r squared, and what h equals in terms of r. And again, what Brooke, what did h? 2r. So the volume, when I clean all this up, I still haven't done any calculus yet. I get that. Isaiah, what is the derivative of the volume over time? I need to do how is volume changing over time? How is radius changing over time? How is height changing over time? Everything is derivative with respect to time.
2 pi r squared dr dt.
And what's on the other side? Changing over time?
Y
dv dt. So over here, he multiplied by the power, lowered the power, and then did the derivative with respect to time. Okay? dv dt in the cone. Tessie, how much volume were we losing in the cone per minute? Negative 10. 2 pi. How fast are we losing? When the coffee is 5 inches deep. When the coffee was 5 inches deep, what is the radius? When the coffee is 5 inches, the radius is half that. So 5 over 2 or 2.5.
Wait, can we not actually find the radius because we still have the unknown variable of GRTT?
Okay, in the problem, which I'm using a piece of information for part A to do part B. It said the height of the coffee in the cone right at this split second. It's going out, but right at this split second, the height of the coffee was 5 inches. So the radius is half that. So I can calculate R. And I get dr dt. I did it wrong again. I did it wrong last week and I did it wrong again.
Yeah.
All right. But dr dt in all of this, negative 10 over 2 pi 6.25.
Where did that come from?
What's 2.5 times 2.5? What is 2.5 squared?
Yeah,
The answer is 6.25.
So Siri provides. Or you can just trust the math teacher knows. But that's cool. We can
Well, I
turn
was
to
just
Siri.
asking where it was coming
Whatever.
from.
I don't take
doubting.
any offense at all.
I wasn't doubting. I was just asking where.
Okay, but somebody help me out. That's got it. Yeah, Josh, you have your calculator. What does it come out as a decimal? I like what pi in there.
You want to have a calculator?
You can type it in.
What?
So be careful about using parentheses. But whatever this is, I still found the wrong thing. But Roisin, you were the one to tell us how to get out of this. I wanted to know how is the coffee level falling. I found dr dt.
Negative 0.255.
Negative 0.0255.
No, it's 0.255.
Okay. Let me see a second. Just checking. So if we type in negative 10 divided by parentheses, 2 pi times 2.5 squared, close some parentheses, negative 0.2.546479089 da 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 da.
Oh, we're supposed to have the
Okay.
whole.
No. I just wrote all those to show a point. How many decimals do you have to keep? 3. You can truncate, which just means cut it off at 3. Or, you're right, that's 4. Or you could, so truncate, you could say negative 0.254. Or you can round, which is negative 2.55. So you were correct, David, in saying that, and Liv would be correct in saying negative 0.254. But I still didn't find the answer that I was asking for. Roisin, how do I get the answer? How is height changing? How about we do the derivative of this with respect to time? Abby?
Is it, dh dt equals 2 times dr dt?
Okay, so this is to say, don't go back and change everything.
So
How is,
everything we did leading up to this was pointless.
no, it was not pointless at all.
So finding DRGT
Yeah, because we
is useful at some point?
Right, just double that. Versus, Eric, if,
Wait.
to go backwards and say, I needed to replace R. So this is h over 2 and h over 2 squared. The number of you that are going to remember to double the number in the denominator is very, very, very little.
I didn't even understand what you just
Okay. Replacing R in terms of h, you get a fraction, and you're going to have to square that fraction, and the majority of you will make a common mistake. So this wasn't bad, but I just found the wrong thing. But I can connect them. So double that, and I get my answer.
Just delta math ask questions like that.
Yeah, just to yank your chain. So, do the delta math, and I would love to do more of these problems, like these textbook problems. They are the harder ones. They are the kind that you will see on the AP exam. The ones that are in delta math are not as hard, but the delta math is what is going into the grade book.
I have a question. Find this on